And we are live. Welcome, everyone, to another Coatings Talk live stream, where we bring clarity, context, and real world insight to the protective coatings and corrosion industries. I'm your host, Jim Kunkel, and whether you're joining me from the field, the lab, or the office, or maybe you're halfway around the world, I'm so glad you're here with me. This live stream is about elevating the coatings and corrosion industries through education, conversation, and community. Every stream, I break down the technologies, the standards, and the strategies that keep critical assets protected. And we do it in a way that's accessible to students, early career professionals, inspectors, applicators, engineers, and asset owners alike. Today's broadcast continues that mission. The world is navigating a period defined by intersecting global pressures. You have aging infrastructure, climate geopolitical uncertainty, and accelerating demands on energy, water, and transportation systems. Extreme weather events, supply chains remain fragile, and many nations are grappling with decades old assets that were never designed for today's operational stresses. In this environment, corrosion isn't just a technical issue, it's a strategic vulnerability. It quietly erodes the reliability of pipelines, bridges, tanks, treatment plants, and industrial facilities at a time when resilience has never mattered more. Corrosion's impact is both immediate and long term. A single coating failure can shut down a production line, it can contaminate a water system, or trigger costly emergency repairs. Now, across the globe, asset owners are confronting the reality that corrosion accelerates under harsher climates, more aggressive service environments, and increased operational loads. These economic consequences are staggering, but the human environmental stakes are even higher. When corrosion compromises critical infrastructure, communities feel that effect, from service disruptions to safety risk and to loss of public trust. This is why field level understanding has become essential. The frontline professionals who inspect, maintain, and protect these assets are the first line of defense against a challenge that is growing in scale and complexity. Their ability to recognize early warning signs, understand mechanisms, and apply protective strategies directly, that influences the resilience of the systems society depends on every day. And I'm very proud to say that this segment is brought to you by Appellix Drone Solutions, who are the leaders in robotic spray painting technology for industrial coatings. If you're an industrial painting contractor or an asset owner looking to boost productivity, improve safety, and deliver more consistent coating results on vertical structures, it's time to take a serious look at spray painting drones from Appellix. These aren't consumer drones. They're purpose-built, engineered industrial drones that solve real field-level challenges, and they support your bottom line, as well as provide you additional revenues and profits with the use of these drones. Appellix spray painting drones allow your crew to apply liquid coatings to elevated, hard-to-reach structures without ever stepping onto scaffolding or lifts. And this means fewer safety risks, fewer delays, and dramatically lower setup costs. And because the drone maintains a precise standoff distance and travel speed, you get uniform field builds, reduce overspray, and repeatable quality across every pass. Imagine completing a tank exterior or a stack or a tall structure in a fraction of the time with a smaller, focused crew safely on the ground, managing the operation. Now, that's the power of Appellix. It's not about replacing painters, it's augmenting your production, giving your team a smarter, safer, more efficient way to work. Now, if you want to improve margins and you want to show that you're an innovator and that you do deliver high quality results with smaller labor demands, Appellix spray painting drones are the competitive edge that you've been waiting for. You can email me at jim@procoattech.com to learn more about Appellix and discover how drone applied coatings can transform your next project. So let's talk a little bit about, developing that understanding of corrosion at the field level. Now, why field level corrosion understanding matters? It comes down to safety, to cost, to compliance. And also, you want to have a strong understanding of corrosion because it's the most important related to the safeguards for a company, because safety begins where work is actually performed. When frontline professionals recognize early corrosion indicators, subtle discoloration, coating holidays, moisture water traps, underfilm blistering, they become more of a first barrier against failures that could put people at risk, especially with critical infrastructure. Many of the most serious incidents in industrial history didn't start with a catastrophic event. They really started with small, usually overlooked signs of deterioration. Now, by empowering field teams with practical corrosion knowledge, that reduces the likelihood of leaks, structural failures, and hazardous exposures. And this protects both workers and the surrounding communities. Cost control is another major reason for this that this knowledge matters. Corrosion is a compounding problem. The longer it goes unnoticed, the more expensive it becomes to repair. A minor coating defect caught early might cost a few hours of touch-up work. That same defect ignored for a few years could evolve into steel loss, unplanned shutdowns, and full-scale rehabilitation. Field level awareness helps companies shift from reactive spending to proactive maintenance, and this extends asset life cycles. It reduces emergency repairs and it improves the total cost of ownership. In a time when budgets are tight and skilled labor is stretched, this kind of mindset is a competitive advantage. Compliance adds a third layer of urgency. Regulatory bodies increasingly expect asset owners to demonstrate proper inspection documentation and maintenance practices, and corrosion is central to all three. Field personnel who understand corrosion mechanisms and failure modes are better equipped to meet standards, maintain accurate records, and support audits. Whether it's environmental regulations, safety codes, or industrial specific requirements, compliance starts with what happens on the ground. When field teams understand the why behind corrosion control, businesses stay aligned with the regulatory expectations and they avoid costly penalties or operational restrictions. So let me just ask you, what corrosion challenges do you see most often? So let's talk about what is corrosion and let's give it that field definition. Let's break it down and make it more simple. Think of corrosion at its core as a natural chemical reaction. Metals returning to their lowest energy, most stable state. In the field, the simplest way to visualize that is to imagine metal trying to go back into the earth. When steel is exposed to oxygen and moisture, it begins to form iron oxide or rust. This isn't a random decay, it's predictable. It's an electrochemical process where tiny areas on the metal surface, they act like miniature batteries. Some spots become an anodic where metal dissolves, and others become a cathodic where the reaction is completed. Even though you can't see these microcells forming, the results become visible as discoloration, surface roughness, or surface scale, and the early signs that the metal is actively breaking down. A helpful field analogy is to think of corrosion as a slow leak of metal atoms. Every time moisture, oxygen, or contaminants touch the surface, a few more atoms are pulled away and converted into corrosion products. Over time, this leak becomes visible as rust layers, pitting, coating blisters, and the process accelerates when salts, pollutants, or trapped moisture are present because they make it easier for electrical current to flow across the surface. And this speeds up the electrochemical reaction. This is why coastal assets, including also in industrial zones and poorly drained structures, well, they corrode faster than clean, dry environments. For field professionals, understanding corrosion as a chemical process, not just a visual defect, changes the way that we approach inspection and maintenance. When you know that corrosion begins long before rust appears, you start looking for the conditions that trigger it: standing water, coating holidays, dissimilar metals, or areas where contaminants accumulate. This mindset helps teams catch problems earlier, apply coatings more effectively, and also protect assets with greater precision. So, what are some of the common misconceptions? Let's think of it as rust. It's just cosmetic. Many field professionals and even some asset owners still carry misconceptions about what corrosion actually is. It's one of the most common is that the belief is that rust is cosmetic. In reality, rust is a visible symptom of a deeper chemical process that has already begun to remove metal from the structure. By the time discoloration or flaking appears, the metal has already lost some mass, and net electrical chemical reaction is driving that loss, and it's very active. Treating rust as a surface blemish rather than a structural warning sign, it leads to delayed maintenance, hidden deterioration, and ultimately higher risk. Another misconception is that corrosion only matters when it becomes severe or when equipment starts to fail. In truth, corrosion begins long before it becomes obvious. Moisture trapped under insulation, a small coating holiday, or two dissimilar metals touching can initiate corrosion that remains hidden for months or years. Field teams who assume if I can't see it, it's not happening, they often miss the early stage damage that could have been addressed with simple, low-cost interventions. Corrosion is not just a sudden event. It's a continuous process, and it's the field person's job to interpret it before it accelerates. There's also a tendency to believe that coatings alone stop corrosion, no matter the conditions. Coatings are powerful tools, but they're not a magic shield. Poor surface preparation, insufficient film thickness, contamination, or environmental extremes can compromise even the best coating system. When field professionals understand that coatings control corrosion rather than eliminate it, they approach the application and inspection with far greater precision and accountability. Now, cleaning up these misconceptions is essential because they shape how teams behave in the field. When professionals understand that corrosion is active, it's progressive, and often hidden, they become more vigilant, more proactive, and more effective at protecting the assets entrusted to them. So, what I want to emphasize is that corrosion is predictable, it is preventable, and it is manageable. Now, corrosion may look unpredictable in the field, but the truth is that it follows clear, well understood patterns. When metal, moisture, oxygen, and contaminants interact, corrosion begins. And when these conditions are controlled, corrosion slows or stops. This predictability is one of the most powerful advantages we have. Field professionals who understand the environment, the materials, and the mechanisms at play can anticipate where corrosion will start, how fast it will progress, and what warning signs will appear first. Instead of treating corrosion as a mystery, we treat it as a process governed by chemistry, environment, and time. Because corrosion is predictable, it's also preventable. Proper surface preparation, the right coating system, correct film thickness, and environmental controls during application, they all interrupt the corrosion cycle before it can even take hold. Even after assets are in service, routine inspections, moisture, water management, and early touch-ups can stop small defects that become major failures. Corrosion doesn't just happen, it happens when conditions allow it. And when field teams understand those conditions, they gain the ability to intervene early and effectively. And most importantly, corrosion is manageable, even in aggressive environments, even on aging infrastructure. The combination of trained eyes, good documentation, and disciplined maintenance practices that keeps assets safe and operational. Field level understanding turns corrosion from a crisis into a control variable. It empowers frontline professionals to protect the integrity of pipelines, tanks, bridges, and industrial systems with confidence. When teams recognize that corrosion is not fate, but a process they can influence, they become the strongest line of defense and asset preservation. So I'm going to cover what I consider my top 3 corrosion mechanisms encountered in the field. The first one I want to talk about is uniform corrosion, and this is going to be widespread surface stack. Uniform corrosion is one of the most common and most easily recognized form of corrosion in the field, but it's also one of the most underestimated. This mechanism occurs when the entire exposed surface of a metal corrodes roughly at the same rate. and it creates a widespread, even layer of metal loss. To the untrained eye, it may look like a simple, uniform rust film and nothing dramatic, nothing localized, nothing alarming, but that broad, consistent attack is quietly thinning the metal everywhere at once. Over time, this steady reduction of wall thickness can compromise structural integrity. It can reduce pressure handling capabilities and also shorten the service life of tanks, of pipes, and also and things that support other critical components. What makes it uniform, it's particularly important for field professionals really, is its predictability. Because the attack is evenly distributed, it's possible to estimate corrosion rates, forecast remaining life, and plan maintenance with a high degree of confidence. But that only works where teams are actively monitoring surfaces, measuring the thickness or looking at normal aging. Assets can reach critical loss thresholds without anyone realizing how much metal has disappeared. The key is recognizing that even slow, steady corrosion adds up, and that early intervention through coatings, surface prep, and environmental controls really can dramatically extend asset life cycles. For frontline inspectors and applicators, uniform corrosion is a reminder that corrosion doesn't need to be dramatic or to be dangerous. A surface that looks evenly weathered may still be losing metal at a rate that demands attention. By understanding how this mechanism works and how it progresses, field teams can make informed decisions. They can prioritize repairs and ensure that assets remain safe, reliable, and compliant throughout their life cycles. The next form of corrosion I want to talk about is galvanic corrosion, and this is dissimilar metals in contact. Galvanic corrosion is one of the most common and most avoidable corrosion mechanisms that's encountered in the field. It occurs when two dissimilar metals come into direct contact in the presence of an electrolyte, such as moisture, condensation, or salt water. In that moment, the metals form a tiny electrical circuit. One metal becomes the anode, and the other begins to corrode faster than it would be on its own, while the other becomes a cathode and is protected. This process is driven by the natural differences in electrical potential between the two metals. Field teams often see this mix metal fasteners, clamps, supports, or repairs that were a quick fix. They were unintentionally, what they've done is they've created a corrosion cell that accelerates metal loss on a more active material. And what makes galvanic corrosion especially important for field professionals is how quickly it can progress once the cell is established. A carbon steel component connected to stainless steel, for example, can experience rapid localized attack that goes far beyond normal uniform corrosion rates. And the damage often appears as concentrated pitting or deep grooves near the connection point. Smaller areas that can lead to big failures if overlooked. Environmental factors amplify the problem. Coastal salt, industrial pollutants, and standing water all increase connectivity, and that makes the galvanic reaction more aggressive. The good news is that galvanic corrosion is highly preventable when field teams understand the mechanism. They use compatible metals instead of installing insulated gaskets or sleeves, applying proper coatings, and eliminating unnecessary metal-to-metal contact are straightforward ways to break the galvanic circuit. Even simple awareness, recognizing when two metals don't belong together, that could stop a future failure before it starts. When frontline professionals understand how galvanic corrosion forms and how to interrupt it, they gain a powerful tool for protecting assets and extending service life. And I want to talk about localized corrosion next. This is going to be related to, let's say, pitting corrosion, crevice corrosion, and really this is hidden but dangerous. Now, localized corrosion is one of the most dangerous forms of corrosion because it concentrates damage into a small, often hidden area that can lead to sudden and unexpected failures. Unlike uniform corrosion, which spreads across the surface, localized corrosion attacks in a highly focused zone, tiny pits, narrow crevices, or shielded pockets where moisture, salts, and contaminants become trapped. These microenvironments create aggressive conditions that accelerate metal loss far beyond what the surrounding surface experiences. And a component may look healthy from the outside, but just a few millimeters away, a deep pit could be silently eating through the metal. And what makes localized corrosion especially challenging in the field is that how easy it escapes detection. Pitting can form behind coatings, under insulation, behind gaskets, and also in tight joints where inspectors can't easily see it or probe. Crevice corrosion often develops in places where two surfaces meet, lap joints, bolted connections, clamps, or deposits sitting on the metal. And these areas restrict oxygen flow, creating a chemical imbalance that drives rapid attack. And by the time visible signs appear, the damage may already be severe, with pits penetrating deeply or crevices undermining structural integrity. Now, for field professionals, understanding this form of corrosion, localized corrosion, this really means adopting a mindset of vigilance. It requires knowing where these hidden threats tend to form, using the right inspection tools, and recognizing subtle indicators such as coating blisters, rust staining, or unexpected moisture. Localized corrosion may start small, but its consequences can be enormous, from leaks and unplanned shutdowns to catastrophic failures. When frontline teams understand how and where it forms, they gain the ability to catch these silent attackers early and predict where critical assets before they become damaged, and that damage becomes irreversible. So I want to talk a little bit about the Corrosion Technician Association, the CTA. This is a not-for-profit organization that's dedicated to elevating the professionals who protect the world's most critical assets. If you're a corrosion technician, an inspector, or anyone working hands-on in corrosion control, there's never been a better time to join the CTA. Our industry is changing fast. There are new regulations, there's new technologies, there's new expectations, and technicians are the ones that are carrying the responsibility into the field. CTA exists to make sure that you're not carrying it alone. The Corrosion Technician Association gives you a unified voice, real professional recognition, and a community built around your success. Members gain access to training opportunities, networking, shared best practices, and resources designed specifically for the challenges technicians face every day. This is about strengthening your career, expanding your knowledge, and connecting with people who understand the work because they live it too. Whether you're new to the field or a seasoned professional, CTA is building the future of corrosion workforce. And your experience, your insight, and your leadership belong in that conversation. When technicians come together, the entire industry gets stronger. So join the Corrosion Technician Association today. Become part of a movement that's raising the standard for our profession. Visit the CTA website to learn more and to get involved. Let's talk about field indicators and early warning signs. What inspectors and applicators should look for. Field professionals are the first line of defense against corrosion, as I said earlier, and their ability to spot early warning signs can make the difference between simple touch-ups and major asset failures. Inspectors and applicators should also pay close attention to subtle surface changes that often signal the beginning of corrosion activity. Now, these include discoloration, dulling of the coating, small rust blooms, or areas where the surface texture feels rougher than the surrounding metal. Even minor blistering, pinholes, or hairline cracks in the coating can indicate moisture intrusion or underfilm corrosion beginning to take hold. And these early cues are easy to be overlooked during a fast-paced field work, but they are sometimes the most reliable indicators that the corrosion process has already started. Another critical area of focus is the presence of moisture water traps and environmental stressors. Inspectors should look for standing water, condensation, salt deposits, or debris buildup, all of which can create microenvironments that accelerate corrosion. Pay special attention to welds, edges, bolts, clamps, and areas where two surfaces meet, because these locations often experience higher stress, are more prone really to coating breakdown. Applicators also be alert to improper surface preparation, inconsistent film thickness, or overspray that leaves thin, vulnerable spots. These application related issues may not show immediate corrosion, but they set the stage for premature failures once the asset's back in service. And by training the eye to recognize these early indicators, field teams can intervene before corrosion becomes severe. This proactive mindset not only protects the asset, but it also reduces long term maintenance costs and enhances safety across the entire operation. Surface changes, coating failures, discoloration, and moisture, water traps, as I mentioned, these are always clues that corrosion can and is beginning to take hold. So they are very easy to miss if you're not intentionally looking for them. A surface that once appeared smooth and uniform may start to feel slightly rough, gritty, or uneven, and you might notice the dulling of the coating, small areas where the gloss has faded, the subtle texture differences that don't match the surrounding metal. These early shifts are important because they might signal that the protective barrier is being compromised. Even minor discoloration, a faint orange tint, dark streaking, or unusual shading can indicate that oxidation has already started beneath the surface. When field teams learn to recognize these small changes, they gain the ability to intervene long before damage becomes severe. And coating failures are another critical early warning sign. Blistering, pinholes, cracking, peeling, or lifting the edges at the point to where moisture intrudes or there's a loss of adhesion. These defects may look small, but they create direct pathways for oxygen, water, and contaminants to reach the metal. Once this happens, corrosion accelerates quickly. Moisture, water traps are especially dangerous because they create microenvironments where corrosion thrives. So when you see standing water on horizontal surfaces or condensation under insulation, even when you have debris buildup or tight crevices where moisture can't escape, these all contribute to rapid deterioration. And these areas corrode faster than exposed surfaces because the trapped moisture keeps the electrochemical reaction active around the clock. When inspectors and applicators train themselves to spot these early indicators, surface changes, coating issues, discoloration, moisture, water traps, they dramatically increase their ability to prevent failures. And these signs may seem minor in the moment, but they're the earliest, most reliable signals that corrosion is underway. Catching them early allows teams to take corrective action, protect the asset, and avoid costly repairs or unplanned downtime. And it's important to document and also take photos as evidence. Documentation and photo evidence are some of the most powerful tools that a field professional can use to stay ahead of the corrosion. Corrosion is a progressive process, and without clear record of what the asset looked like last month, last season, last year, it becomes nearly impossible to track how quickly conditions are changing. Written notes, inspection logs, and timestamp photos create a baseline that helps teams identify trends, whether a small blister is growing, whether discoloration is spreading, or another moisture water trap is becoming more active. This historical perspective allows inspectors and asset owners to make informed decisions about maintenance timing, coating repairs, and risk prioritization. Photo evidence also brings clarity and credibility to the field observations. A well-taken image can capture details that words alone might miss. The exact shape of a blister, the depth of a pit, pattern of rust staining, or the presence of contaminants. These visuals become essential when communicating with supervisors, engineers, coating manufacturers, or third-party inspectors. They eliminate uncertainty and ensure everyone is looking at the same reality. In many cases, photos can even prevent disputes by providing an objective proof of the conditions at the time of the inspection. Beyond internal communication, documentation and photos support regulatory compliance and audit readiness. Many standards require traceable inspection records, and photo evidence strengthens those records by showing not just what was found, but how it appeared in the field. When a company can demonstrate consistent, detailed documentation, it builds trust with the regulators, the clients, and stakeholders. Ultimately, strong documentation practices empower field teams they improve decision makers, and they help protect the long term integrity of critical assets. Environmental and operational factors: how humidity, temperature, salt, and industrial pollutants accelerate corrosion. Humidity, temperature, salt, and industrial pollutants are some of the most influential environmental factors driving corrosion in the field. And understanding how they work gives a frontline professional a major advantage. High humidity increases the amount of moisture available on metal surfaces, creating a thin, invisible film of water that enables the electrical chemical reactions behind corrosion. Even when surfaces look dry, moisture in the air can condense in shaded areas, under insulation, or on cool metal during temperature swings. Temperature plays a dual role. Warmer conditions speed up chemical reactions, while rapid temperature changes cause condensation cycles that repeatedly wet and dry the surface. Each cycle restarts the corrosion process and accelerates metal loss over time. Salt is one of the most aggressive accelerators of corrosion because it dramatically increases the conductivity of the moisture in the metal surface. In coastal regions, marine environments, or areas exposed to de-icing salts, chloride ions penetrate coatings, disrupt protective films, and create highly active corrosion cells. Salt doesn't just sit on the surface, it absorbs moisture from the air, keeping the metal wet even in conditions that would normally be dry. This is why assets near coastlines or roadways often corrode faster and require more frequent inspection and maintenance. Industrial pollutants add another layer of complexity. Sulfur dioxide, nitrogen oxides, and other airborne contaminants combine with moisture to form acidic films on metal surfaces. And these acids break down coatings, they attack steel, and they create localized corrosion hotspots. Facilities near refineries, chemical plants, or heavy manufacturing areas often experience accelerated corrosion rates because pollutants settle on the surface and react with moisture. When humidity, temperature fluctuations, salt, and pollutants interact, they can create a perfect storm, an environment where corrosion thrives unless protective measures are consistently applied and monitored. For field professionals, recognizing how these environmental factors work is essential for predicting where corrosion will appear first and how quickly it will progress. This awareness gives inspection priorities, coating selection, maintenance planning, and overall asset protection strategies. So, the role of design flaws in poor coating application. Design flaws play a major role in how quickly corrosion develops, often creating conditions that even the best coating system can't fully overcome. When assets are built with sharp edges, tight crevices, and complex geometries, or hard to reach surfaces, these areas naturally become corrosion hotspots. Edges tend to receive thinner coating films, crevice traps moisture and water, and contaminants. And intricate designs make it difficult for applicators to achieve proper surface preparation. Poor drainage is another common design flaw. Flat surfaces, horizontal ledges, or improperly sloped structures allow water to pool, and this creates a long-term moisture trap that accelerates corrosion. These issues aren't just obvious during the construction, but in the field they become more persistent sources of coating failure and metal loss. Poor coating application compounds these design challenges. Even the most advanced coating system will fail prematurely if it's not applied over if it's applied over inadequate surface preparation, contaminated steel, or inconsistent film thickness. Thin spots, overspray, missed edges, and improper curing conditions all create weak points where corrosion can initiate. In many cases, the coating may look acceptable on the first day, but hidden defects like embedded dust, trapped solvents, or incomplete surface cleaning become undermining, and they undermine the adhesion from the moment the asset enters surface. When environmental conditions such as humidity or temperature are outside the recommended range during application, the coating may never achieve its intended performance, and this leaves the asset vulnerable long before its expected service life. Together, design flaws, and poor application practices create the perfect storm for early corrosion. Field professionals who understand these risks can better identify vulnerable areas, adjust inspection priorities, and advocate for corrective actions before failures occur. And this awareness transformed corrosion control from a reactive task to a proactive strategy, protecting both the assets and the people who depend on it. So let's talk about in coastal environments, because they're some of the harshest corrosion zones on the planet. And the field professionals working near ocean, sea, and the coast, they really see this firsthand. Salt-laden air carries chloride ions that settle on metal surfaces. They get into coatings and they can dramatically increase the conductivity of the moisture present. Even when equipment appears dry, salt can still pull moisture in from the air and keep that surface continually active, accelerating corrosion day and night. Coastal assets often show faster coating breakdown, more aggressive pitting, and higher rates of uniform corrosion compared to inland structures. In contrast, inland environments, especially dry or low humidity regions, tend to experience slower corrosion rates, but inland doesn't mean immune. Industrial pollutants, temperature swings, and moisture traps can also still create highly corrosive microenvironments, especially around equipment that cycles between hot and cold or sits near chemical processing operations. Buried assets introduce a completely different set of challenges. Soil chemistry, moisture content, and oxygen availability all influence corrosion rates underground. Certain soils, such as those in high chloride, sulfates, or organic acids, can be extremely aggressive by attacking steel even when the coatings or wraps are present. Buried pipelines, tanks, and structural support often corrode out of sight, making early detection difficult without proper monitoring systems. On the other hand, exposed assets face direct environmental assault. UV radiation, rain, temperature fluctuations, and airborne contaminants all contribute to a coating's deterioration and ultimately lead to metal loss. Exposed structures like tanks, bridges, and above ground piping experience more visible corrosion, but they also benefit from easier inspection access. These field examples highlight why corrosion control strategies must be tailored to the environment and asset type. Coastal versus inland, buried versus exposed, each scenario presents a unique risk that frontline professionals must understand to protect assets effectively. So let's talk about coating systems and field level protection strategies. Coatings are one of the most effective tools that we have for interrupting the corrosion process. And understand how they work gives field professionals a clearer sense of why proper application and inspection matter so much. At the moment, the most basic level, coatings act as a physical barrier between the metal and the environment by preventing oxygen, moisture, and contaminants from reaching the steel surface. They break the electrochemical cycle required for corrosion to occur. And when the barrier is intact and properly applied, the metal underneath remains isolated from the corrosive elements that would otherwise trigger uniform corrosion, galvanic reactions, or localized attack. This is why surface preparation and film thickness are so critical. Any gap, thin spot, or a defect becomes a direct pathway for corrosion to begin. Beyond the simple barrier protection, many modern coatings incorporate active corrosion control mechanism. Zinc-rich primers, for example, provide sacrificial protection by corroding preferentially to steel, effectively taking the hit and preventing galvanic corrosion from attacking the substrate. Other coatings contain corrosion inhibitors that neutralize contaminants or slow down chemical reactions at the metal surface. Some systems are engineered to resist specific threats like chlorides in coastal environments or acids in industrial settings. When these systems are applied correctly, they don't just delay corrosion, they fundamentally change the environment at the metal interface, making it less likely for corrosion cells to form. For field level professionals, recognizing how coatings interrupt corrosion mechanisms, it reinforces why every step of the process matters, from surface prep and environmental controls to inspection and maintenance, a coating isn't just paint. It's a carefully engineered system designed to stop corrosion before it starts. And when applied with precision and maintained with vigilance, coatings become one of the strongest defense we have for extending asset life and ensuring long-term reliability. So when it comes to surface prep, film thickness, and cure time, why do they matter? Surface preparation, film thickness, and cure time are the three pillars of any successful coating system. And in the field, they determine whether a coating becomes a long-term protective barrier or an early failure waiting to happen. Surface preparation is the foundation. If contaminants, mill scale, rust, or salts remain on the steel, they create weak points where corrosion can immediately restart beneath the coating. Even the most advanced coating chemistry cannot bond properly to a dirty or poorly profiled surface. A clean, dry, correct profile substrate gives the coating something to bite into, creating mechanical adhesion strong enough to withstand surface conditions. And when surface preparation is rushed, or compromised, the coating may look fine on day one, but the adhesion loss and blistering and under film corrosion often follow soon after. Film thickness is equally critical because the coatings are engineered to perform within a specific thickness range. Too thin and the coating lacks the barrier strength needed to keep moisture, oxygen, and contaminants away from the steel. Thin spots often occur on edges, welds, and complex geometries, exactly the areas that are most vulnerable to corrosion. Too thick and the coating may crack, trap solvents, or cure improperly, and this leads to premature breakdown. Achieving uniform, verified film thickness ensures the coating system delivers the protection that it was designed for, especially in immersion or high-stress environments. Cure time completes the equation. Coatings need proper time and the right environmental conditions to fully cross-link and develop their intended chemical and mechanical properties. If a coating is exposed to moisture, low temperatures, or even service conditions before it's cured, its protective network may never fully form. And this results in soft films, poor adhesion, and reduced resistance to chemicals or abrasion. Field teams who respect cure schedules and monitor temperatures, humidity, and the dew point give the coating the chance to reach its full potential in performance. Together, surface prep, film thickness, and cure time form a chain, and like any chain, it's only as strong as its weakest link. When field professionals understand why each step matters, they gain the ability to prevent failures before they start and ensure that every coating system performs as intended throughout its asset life cycle. Now, here are some common field mistakes and how to avoid them. Common field mistakes often stem from rushing, improvising, or assuming that a small deviation, it doesn't matter. But in the coatings work, the smallest misstep could possibly become a root cause for a major failure. And one of the most frequent issues is inadequate surface preparation. When contaminants, rust, or mill scale remain on the steel, they create weak points where corrosion can immediately restart beneath the coating system. Another common mistake is skipping environmental checks. Applying coatings when humidity is too high, temperatures are out of range, or the surface is near the dew point can lead to poor adhesion, solvent entrapment, or incomplete curing. These problems may not show up right away, but they often reveal themselves months later as blistering, peeling, or under-film corrosion. Film thickness errors are another widespread challenge. Thin spots, especially on edges, welds, and complex geometries, it leaves the substrate vulnerable to early corrosion, while overlay thick films can crack, sag, or cure improperly. Applicators may also overlook mixing and induction requirements, leading to coatings that never fully cross-link or achieve their desired performance. Even simple oversights like failing to stripe coat high-risk areas or neglecting to clean equipment between coats can compromise the entire system. Avoiding these mistakes starts with discipline and awareness. Field teams should follow surface preparation standards rigorously. Verify environmental conditions before and during the application, and use calibrated gauges to confirm film thickness. Proper training, clear communication, and consistent documentation helps to ensure that every step is executed correctly. But when frontline professionals understand not just what, but why, it matters that they become far more efficient and effective at preventing failures and ensuring that coating systems can deliver long-term protection. Let's talk about empowering field professionals and why field level knowledge is critical to asset integrity. Field level knowledge is the backbone of asset integrity because corrosion doesn't start in a conference room or a design model. It starts on the steel, in the environment, and in the day-to-day realities that frontline professionals see up close. Inspectors, applicators, and technicians are the first to notice subtle changes in shifting in surface texture, a small blister forming, a moisture water trap developing, or a coated edge beginning to lift. These early indicators rarely show up in reports or dashboards until it's much later. But field professionals catch them in real time. Their ability to recognize what is normal, what it really looks like, and what it doesn't gives companies the earliest possibility of warning that corrosion is beginning to take hold. Without that frontline awareness, small issues can grow into major failures long before anyone realizes what's happening. Firsthand knowledge is also critical because it connects theory to reality. Specifications, standards, and engineering models assume ideal conditions, but in the field is so full of variables. Weather shifts, access challenges, unexpected contaminants, and equipment limitations. Professionals who understand corrosion mechanisms, coating behavior, and environmental impacts can adapt intelligently when conditions change. They know when a surface needs additional prep, when a coating isn't curing properly, or whether a design flaw is creating a long-term risk. This practical judgment, grounded in experience and technical understanding, is what keeps assets safe, compliant, and reliable. Ultimately, asset integrity depends on the people closest to the work. When field professionals are empowered with knowledge, training, and the confidence to speak up, they become the strongest defense against corrosion-related failures. These insights drive better decisions, more effective maintenance strategies, and a culture where asset protection is proactive rather than reactive. So I want to highly encourage everyone to pursue training, certification, and importantly, focus on cross-team communication. Now, training, certification, and strong cross-team communication, they're really some of the most powerful ways to elevate field professionals and also strengthen overall asset integrity. When inspectors, applicators, and technicians pursue ongoing training, they stay current with the evolving standards, new coating technologies, and emerging corrosion control practices. Certification programs, manufacturer training, or internal competency pathways give professionals in structured way to validate their skills and demonstrate their expertise. This not only boosts individual confidence, but it also builds trust across the company. When certified professionals speak up about a concern, recommend a repair, or flag a risk, their voice carries weight because it's backed by recognized credentials and proven knowledge. Cross-team communication amplifies that expertise even further. Corrosion control is never a one-person job. It requires coordination between inspectors, applicators, engineers, planners, and asset owners. When these groups share information openly, small issues get addressed before they escalate. A technician noticed something an unusual moisture pattern. Well, that can alert to an inspector and applicator, and it can really even flag a design fault that creates a coating challenge. An engineer who can explain operational changes may affect corrosion rates, and this flow of information creates a culture where everyone contributes to asset protection, not just the people handling the gauges or applying the coatings. Encourage training, certification, and communication This is going to empower your field professionals to lead from where they stand. It also reinforces the idea that expertise grows through continuous learning and that the strongest teams are the ones who talk to each other, that share insights, and they collaborate across disciplines. When frontline professionals feel supported, informed, and connected, they become the driving force behind safer assets, better decisions, and more resilient corrosion control programs. So, with that, I'd like to say thank you so much for this opportunity to have this discussion with you. Please feel free to post additional contents or comments, and also to like and share this with other colleagues. So thank you so much. Hopefully you'll have a good rest of your evening, night, or morning, no matter where in the world you're watching this live stream. Thank you.